let's dive right into this explainer. Today, we're taking a look at a totally fascinating 5-day curriculum called The Lab, and it literally revolutionizes how we teach media literacy and scientific reasoning to 5th graders. And the best part, it does it entirely through an immersive simulation. You are absolutely going to love how this works.
To really set the stage here, picture this incredible scenario straight from the source material. You've got a room full of 10-year-olds. A pharmaceutical company has just handed them this super impressive data packet for an allergy medicine. 200 children tested, an 87% improvement. One kid yells out, 87%, that's amazing! Another is frantically flipping through the pages. And then the quiet kid in the back speaks up and says, wait, the control group was only 12 kids. The entire room just goes completely silent. In that moment, as the text beautifully puts it, the methodology just beat the headline.
So that brings us to a really massive challenge. How in the world do you actually teach a 5th grader experimental design? I mean, we all know textbook lectures simply don't work for something like this. Kids, and let's be honest, adults too, we all need to experience the friction of making a bad choice to genuinely learn how to read evidence carefully. Well, the creators of the lab solved this with a brilliant daily structure called the DIE model. Over the course of 5 days, student teams actually operate as an independent consumer safety testing lab. They move through diagnosis to orient the room, intervention where new material gets delivered, implementation where they actually work in their teams, and finally, evaluation where they debrief the whole thing.
Right from the jump, these kids are hit with strict economic constraints. Every single day, they've only got 4 lab stations and 6 scientist hours to work with. They start out with 100 reputation points and just a $200 equipment budget. This scarcity is crucial because it forces them to make really hard choices. They physically cannot evaluate every single product that comes through the door.
And here is where we get to the absolute genius of the simulation, the ultimate guardrail. It's called the methods checker rule. In each team, one student gets assigned this specific role. And the rule is absolute. A team cannot vote on any product until the methods checker reads the full test description out loud. It is literally the single mechanism that forces these kids to pause and evaluate the actual science before reacting to a shiny, exciting claim. Okay, falling into the traps. Let's look at what actually happens on days 1 and 2 of this simulation. Day 1 hits and the products start rolling in. On one side, you've got the Mega Glow flashlight claiming to be 3x brighter. It only takes 1 scientist's hour to test. But the methodology, basically someone just turned it on in a dark room. No light meter, nothing. On the other side, you've got the Clean All water filter. Sounds incredibly boring, takes up 2 precious hours, but it boasts 50 controlled samples using properly calibrated equipment. So what do the kids do? Most of them jump straight at the flashy flashlight and totally skip the boring water filter. But boom! Here is the core design principle of the game revealed. Methodical, undramatic choices structurally outperform dramatic, exciting ones. The boring choice actually wins. The friction they feel when they realize approving that flashlight just tanked their lab's reputation, that friction is the actual teacher. Moving into day 2, the simulation cranks up the complexity. Now we've got Sparkle Fresh toothpaste, claiming 9 out of 10 dentists recommend it. But if that methods checker reads closely, they'll see it was literally just 10 dentists surveyed at a company-sponsored event. Then there's the PowerMax battery. This one comes with a dense, super professional-looking 14-page report full of charts and graphs. But the methodology reveals they totally rigged the temperature conditions to make their battery look better. The game is actively starting to hide bad science behind big sample claims and slick formatting. Which brings us to the pressure test, day 3, and the climax of the whole simulation. A pharmaceutical company bursts in and drops this massive 40-page data packet on the kids' desks for a new children's allergy medicine called Kid Clear. And on the front, it proudly boasts this huge, game-changing number, an 87% improvement in 200 children. And to really turn up the heat, the teacher sets a very visible 5-minute timer right at the front of the room and offers a $100 fast-track bonus for their lab. Thousands of kids in Spark City are suffering from allergies, and they need this medicine right now. The simulation is purposefully creating this intense squeeze between feelings and facts. Will the kids rush the approval, or is that methods checker going to step up and do their job? Well, here's the catch. If the students just read that cover page and don't physically flip to page 12 of that dense packet, they miss a fatal flaw. Out of those 200 children, 188 were given the actual medicine, but the control group, the kids who just got a placebo,
was only 12 kids. It's a highly skewed, tiny little control group that completely invalidates that massive 87% claim.
All right, consequences and recovery. Let's see the fallout on day 4.
Day 4's morning report is absolutely unflinching. The hard truth? Kid Clear's real improvement was actually only 8%, not 87. That original control group was just way too small to detect the real difference. So any lab that approved it immediately loses 10 reputation points. Their approval is completely revoked, and, this is the kicker, they are required to publish a mandatory retraction notice. Meanwhile, those careful labs that actually read the methodology, they're getting repeat verification contracts.
And listen, having to publish a retraction, that is a feature of this game, not a bug. The teacher does not soften the blow here at all. Writing that retraction teaches what the curriculum calls bounce-back thinking. It shows these kids that owning a wrong call and correcting the record is exactly what real, honest scientific labs do. It's honestly wild to think about the incredible journey these students take over just 5 days. They go from this naive enthusiasm, just completely trusting shiny claims, to facing real, tangible consequences, and finally developing genuine skeptical analysis and scientific resilience. So let's wrap this up with the science of thinking in the Day 5 synthesis. First up, the teacher finally puts a name to the wow result. This is exactly the trap they fell for way back on day 1 with that mega glow flashlight. Their brains saw 3x brighter and made a snap decision before they ever even checked how it was tested. Next is the big sample trick. This perfectly names the trap that caught them with the toothpaste and those 10 dentists, and of course, that massive 87% Kid Clear claim. They trusted a big number without checking the tiny, totally biased sample hiding underneath it. And then, of course, there's the shiny report. This is the trap that made them trust that rigged 14-page battery report, simply because it had professional-looking charts and graphs. The crazy thing is, without even realizing they were learning formal pedagogy, these kids built up a profound new framework for reasoning. They've learned to weigh feelings versus facts when they're under immense pressure. And they've developed the absolutely crucial habit of the brain check, literally stopping to notice when they are trusting something just because of how it looks. So I want to leave you with this final, somewhat provocative thought to chew on. When was the last time your brain trusted a shiny report or a really impressive statistic without checking the methodology? Because the honest truth is, every single one of these thinking patterns happens to us adults too. We are all susceptible to the wow results and the big sample trick every day. But just like these 5th graders, once you realize your brain can be tricked, you can start checking. Thanks so much for joining me for this explainer, and hey, keep doing those brain checks.